Hello students, today I am going to explain about how a spark is produced when we close the switch. When we close the switch. See that switch is there. A switch is shown here. The switch is represented by two lines, a high voltage line and a low voltage line, and closing port is shown here. If you push this part, the part will connect to this high voltage line, thereby the electric path will be closed. This is what the construction of the switch. Now the switch is in open state. Here the point is, once you throw the switch, suddenly at very high speed, sometimes you observe sparks. Why such sparks are produced? That is a question. To understand that, first let us see how light is produced. Consider an atom here. Atom has nucleus and it has two orbits. In the first orbit there are two electrons. And when these two electrons receive energy like heat energy or energy by electric field attraction, those electrons will jump from first orbit to higher orbit, and they remain there in the higher orbit for very brief interval, say nanoseconds, and immediately will come back to lower orbit. When they are coming back from higher orbit to lower orbit, they will release energy in the form of light. Okay, and then they jump back to lower orbit. In the process, they release energy in the form of light. See that to move from the lower orbit to higher orbit, they need energy. That energy usually comes from the heat energy or electric field, etc. This is how light is produced. Coming back to the switch, here I have shown one high voltage part. High voltage part is point A. Low voltage point is point B. The low voltage is 0 volts, but high voltage point is 200 volts. That is point A. The distance, the space between A and B is delta x. Initially, the delta x is large. Thereby, the electric field minus delta V by delta x is equal to minus 200 by delta x. Delta V means potential difference between A and B. So 200 minus 0 is equal to 200 volts. That is equal to delta V. If delta x is large, see that in this electric field is equal to minus delta V by delta x. If delta x is large, electric field will be small in the gap of delta x. The electric field will be small. Therefore, air in the gap will not be ionized. But once you are pushing this switch, very closer to high voltage point A, as shown in figure below. Okay, when you are pushing the switch slowly towards point B, at one point the space between A and B is very, very small. That is delta x dash, where A is at 200 volts, B is at 0 volts. Thereby, the potential difference between A and B is 200 minus 0 is equal to 200 divided by delta x dash. Okay, if delta x dash is equal to 0.000001 or 10 power minus 7, when 10 power minus 7 goes to the numerator, it becomes 10 power plus 7. 10 power minus 7 when goes to the numerator, it becomes 10 power 7. Therefore, 200 to 10 power 7 volts per meter. By this large electric field, air will be ionized. Some electrons, by this large electric field, the air, whatever air is present between A and B, will be ionized. Ionized means the electrons of those atoms of the air will go from lower orbit to higher orbit and move back from lower orbit to higher orbit. In the process, they produce light. That is why when you close the switch, suddenly large electric field will be produced. By that large electric field, the electrons of the atoms of the air will move from lower orbit to higher orbit, and they will not remain in the higher orbit for a long time. They will remain there in the higher orbit for nanoseconds and come back to lower orbit. When the electrons are moving from higher orbit to lower orbit, they will release energy in the form of light. Okay, thank you. This is